This is the 6.1c lesson called Expanding Our Number System. Number 1 says we're going to list the sets of numbers we've learned so far, and we're going to go in order from least to greatest. So, and also in order that we normally learn them, which is we start with natural, also known as counting. Then we learn about whole numbers. Whole numbers include 0. Then we learn about negatives, which is integers. Remember that integers also includes the other ones here, so it does actually include positive and 0. Then we learn about fractions and decimals, which is rational. And then we recently added irrational to the list, non-rational. Number 2 says, are all numbers rational? And we kind of just said that everything can't be expressed as a fraction. And some examples of things that can't be expressed as a fraction would be pi, phi, or phi, square root of a non-perfect square, like square root of 2, or square root of 8. Number 3 says, can the square root of 2 be written as a fraction where the numerator and denominator are integers? And we'll say no. It is irrational. Also say the number or decimal does not repeat or terminate. Terminate meant in. Feel free to pause the video. If you feel like you can do some of it without listening to the video, feel free to work ahead and check it. Number 4, we have rational and irrational numbers, which form a larger set. So we're going to add a new set here. We can maybe highlight it, this set. We have this kind of flow chart that shows us how all the sets kind of combine, which is the real number system. So reals includes rational and irrational. So it includes counting numbers like 4, integers like -7, rational numbers like 2/3, and irrational numbers like square root of 11. So more or less everything, at least so far, is going to fall into what we call real numbers. All right, we're going to look at this flow chart that kind of helps us understand this. So the 2 categories as we work down from reals is rationals. Rationals, we're going to give the informal definition because we wrote the formal before, which is decimals that repeat or terminate. So when we convert something that might be a fraction, maybe it's not even a fraction, but if we were to represent it as a decimal and convert it, it needs to repeat or terminate. So 3/5 is 0.6. 0.3 repeating repeats, so that can be represented as a fraction. That's 1/3. 2, just the number 2, repeats or terminates and can be represented as a fraction 2/1. And then 0.5, and let's even just stick a negative number in here as well, like -6. The other category we have, the split, is numbers that are real are either going to fall into rational or they're going to fall into irrational. And this is a non-repeating, non-terminating decimal like pi, phi, or square root of 5, the square root of a non-perfect square. Let's also even maybe add over here a square root that works out nice, like square root of 9. So the 2 numbers that multiply to equal 9 are 3 and 3. So that is a rational. We work our way down. The next category below that is integers. These were natural numbers, 0 and the opposite of natural numbers. Examples would be -5, 0, 6, 10. You can add any other ones you want to. By the way, I'm not sure what this blank is. Okay. And then here's actually an example of some. And then from there, we're going to work our way down to a smaller group, which is known as whole numbers. Whole numbers don't include these numbers over here. Kind of helps us understand the difference here. And whole numbers are natural numbers and 0. And there's 0. There's our example. And then 0 is over here because it's not part of natural, and natural is counting numbers. Right. I was trying to hint about square roots, and square roots mean we need two identical numbers that multiply to equal the number under the square root. So this would be two numbers that are identical to equal 25 or 5, two identical numbers that multiply to equal 16 or 4. But if we think of what are two identical numbers that multiply to equal -49, you can also think of it as a literal square. So what could we apply for these sides to have this area? If we try positive, that doesn't equal negative. And if we try negative, it also equals a positive. And so we're kind of stuck in this paradox that we can't actually satisfy this. So it says, is it possible to simplify the square root of -49 within the real number system? And we'll just say no. We can look at this one, right? So if we see something like this on our table below, we're not going to check that it belongs in any category. This is almost like a trick question, which I guess then begs the question, is there something outside of real? Yeah, there are things called non-reals or imaginary. So number 6, we're going to look at the difference between placement of the negative. If the negative's in front, then we're going to square root square root 4, and we can also type this in the calculator. So we're going to almost ignore this for a second. Square root of 4 is 2. And we're going to maybe just put the negative back on, and we get a negative answer. And then this is not real, so we can't even do it. If we make the 2's both positive, it doesn't work, and if we make the 2's both negative, it doesn't work. All right, we're on the last part, and we're going to now look at classifying numbers, and we're going to put an X or check mark in all the sets they belong to. And if we can find that they belong to one of these smaller sets, we probably can check everything across, except we might just need to be careful in these two. So 2/3 is a fraction, so it's rational, but it's not these. These are not fractions, or these can simplify out. If it's rational, it's not irrational, but it is real. Almost everything here is going to be real. This is a decimal that repeats or terminates, so it's rational and it's real. -2 is a negative number, so it's an integer. And if it's integer, it's rational and it's also real. 0, the smallest set that it was in was whole. And if it's in whole, it's also an integer, rational, and real. Square root of 36. Type that in your calculator and think about that. It is 6. And 6 is natural, whole, integer, rational, real. So it goes in natural, and if you go back to the flow chart, natural was in all these categories except for irrational. Number 12, we can't square root a negative, so we're going to leave this whole thing blank. It doesn't go anywhere. 13 is a decimal that repeats, so that is going to be rational and real. 8 over 0, this was thinking back to module 2 and 3, this was undefined, under the line undefined. And so that actually doesn't belong anywhere because we can't do that. 15, pi is irrational, and tripling it and taking its opposite is still going to be irrational, and therefore it's also real. Square root of 2 is irrational. Cutting in half, it's still going to be irrational. You can type it in the calculator if you don't believe me. 17 doesn't repeat or terminate. There's a pattern, but the number of 2's just keep expanding, so I can't represent this with the repeating bar, and it doesn't stop. So this is irrational and real. And if I have a square with an area of 8, what two numbers, they have to be the same, can I have here that multiply to equal 8? Well, if this was 9, I could choose 3 and 3. But 8's kind of sloppy, it's kind of messy. In order to get that, I'm going to have to square root 8, and that's going to be irrational. We're going to show two different examples of non-real. So what were the two that we saw in this? We saw square rooting a negative, even if it's a perfect square. And another one was dividing by 0. Can't do that. That was actually the example we used above, what we saw. Last thing is we're going to go to our number line, and we're going to do kind of what we did in module 1, where we're going to put dots on here or shade them in and do open or closed circle to represent the numbers. It'll make more sense as we look at this first one. It says we're going to represent whole numbers. So whole numbers were 0, 1, 2, 3, from negative 2 to 4. So from negative 2 to 4, well, this is a trick question because whole numbers don't exist in negatives. So it's going to start here. That's an answer. This is an answer. This is an answer all the way up to 4. And the other thing we should think about is, should we fill in the stuff in between? Decimals and fractions. Whole numbers are not decimals and fractions, so we're only going to include these. Real, from negative 3 to 1. So real numbers can be negative, they can be positive, they can be 0, they can include these. And can reals include all the fractions and decimals in between? And real did include them because real included rational and irrational. So we're going to fill that in. Think back to those inequality graphs from module 1.